Today we are finishing up 6.1 and 6.2 by looking at how to find the area of an oblique or non-right triangle. There are two different formulas for this, and it just depends on what information you are given. So our first formula for area here is 1/2 BC times sine of A. You will use this one if you are given side angle side. So basically, if you know an angle. Now, I will say you may not actually be set up for side angle side. If you know an angle though, you may have to find a side using either law of sines, law of cosines to be able to do this. And just like those formulas earlier, if I don't know angle A, if I know angle B, this is going to be 1/2 AC times sine of B. If I know angle C, it's going to be 1/2 AB times sine of C. So just the two sides can't match the angle that you know. Our other formula for area is the square root of S times S minus A, S minus B, and S minus C. This is actually called Heron's formula. One thing here is that A, B, and C obviously comes from the sides of my triangle. This S, though, you find by adding those three sides and dividing by 2. So since this one only uses sides, you're going to use this one if you know all three sides and you don't know any angles. Find the area of a triangular lot having sides of lengths 90 meters and 52 meters and an included angle of 102 degrees. So I would recommend drawing a triangle. I have sides with 90, 52, and the included angle, so that's the angle between them, is 102 degrees. So clearly not drawn to scale, but at least I can see, oh, that's side angle side, or I know an angle. I need to use my first area formula. So area equals 1/2. I'm going to use my two sides, 90 times 52, times sine of my angle, which is 102 degrees. And then I can just type that all in at once, and I got 2,288.87 meters squared. So that would be the area of that triangular lot. For number 2, find the area of a triangular region having side lengths, A equals 43, B equals 53, and C equals 72. So again, a triangle never hurts. A is 43, B is 53, and C is 72. I know all three sides, so I'm going to use Heron's formula, or that second area formula. First, I need to find S, so I'm going to add my three sides together and divide by 2. When I do that, I get 84. Now I can plug that into my area formula. So the square root of 84 times, then I'm going to do 84 minus 43 times 84 minus 53 times 84 minus 72. Now hopefully most of that you could do in your head. So if you wanted to go straight and type in 84 times 41 times 31 and times 12, that would be fine. When I do that square root though, I'm getting 131.89, and whatever my units were, we'll just say units squared. Meters would be meters squared, feet would be feet squared, so forth. Right, try these couple on your own. I'll put up the answers in a minute so that you can see them and check them. For the first one, since I knew an angle, I was using that first area formula. I did draw my triangle here to make sure that it was side angle side. But I can see up here too that the letters that go with the two sides is not the same letter that I have for that angle. So I set up my formula, made sure I was in degree mode. I got 9.08 units squared for my area. Second one, I had 3 sides, so first I found S and I got 16.5. Then I used that in my Heron's formula, and I got 36.98 units squared. Just a couple more application problems for law of sines and law of cosines. So I have a boat race that starts at point A and proceeds in the direction south 52 degrees west to point B, and then south 40 degrees to 40 degrees east to point C. So I'm going to put A up here. I'm going south 52 degrees west, and I'm going to go, proceeds in that direction to point B, and then in the direction south 40 degrees east to point C. Oops. Now this is crucial here. C is 8 kilometers due south of A. So I'm actually going to make that come straight down to C. And this was 40 degrees east. And finally back to A, the total distance, find the total distance, and I have an 8 here. So I have lots of things I need to figure out. First off, I only have one angle. I need to find some more angles, so let's start with that. To help it stand out a little bit, I'm going to switch colors real quick just so you can see that better. So this north-south line that I have running on the left side, as well as that north-south line that we had on that right side, those are parallel lines. So this 40 degrees and this angle are alternate interior angles, which means they're the same. So I know that that one's 40 degrees. You could have also said that that means this one up here is 52 degrees if you'd like to go that way. But you only really needed one of them because I know all the angles in a triangle add up to 180. So this angle here is 88 degrees. Now that I have that, sine of angle A, which is 52 degrees, over side A, is the same as sine of angle B, which is 88 degrees, over side B, which is actually 8, is the same as sine of angle C, which is 40 degrees, over side C. Cross multiply, divide, so I'm going to have 8 times sine of 52. Then I'm going to be dividing by that sine of 88, and I get that A is 6.3. Same thing for C. I'm going to have 8 times sine of 40, and then I'll divide by that sine of 88, and I'll get that side C is 5.1. And these should all be in kilometers. I want the total distance of the boat race. So my total distance is going to be 6.3 plus 5.1 plus that 8, which is 19.4 kilometers. One more example with these, again with the boat sailing. This time it's going due east, parallel to the shoreline, at a speed of 10 miles per hour. At a given time, the bearing to the lighthouse is south 70 degrees east. So just real quick, my lighthouse would have to be on the shore. So from the boat to the lighthouse is going south. So my boat's going to be up here. My lighthouse is down here. My shore is. So boat is sailing due east at a speed of 10 miles per hour. At a given time, the bearing of the lighthouse, bearing to the lighthouse, so let's put our lighthouse right there, is south 70 degrees east. And 15 minutes later, so I'm still going this way, 15 minutes at 10 miles per hour, would give me having gone 2.5 miles. Now my bearing is south 63 degrees, so I'm actually going to shrink this picture a little bit. Let's put my boat right here. Let's just say I've only gone a little bit. And then I have that south 70 degrees to my lighthouse. I go 2.5 miles. And now I'm south 63 degrees to the lighthouse. Find the distance from the boat to the shoreline if the lighthouse is at the shoreline. So I do actually want to find this distance here. First off, this triangle, I need that full angle. So that full angle should be 90 plus 63, which would be 153 for that angle. So I want to get that filled in. I also want to see if there's anything else that I can fill in. So that's 153 degrees. I know my 2.5. Oh, I know this angle would be 20 degrees because going due east or due south would be 90-degree difference there. Which means I know that this angle is 70 degrees because all the angles in a triangle add up to 180. So maybe it would help if I redrew it first with the actual big triangle I'm looking at. So I have my 2.5 here, 20 degrees, 153 degrees, and 7 degrees. If I could find this distance here, I'm just going to call it B. Then I do have a right triangle here that I could use. So I'm going to draw that down here so that we can see it. So I want to find this distance D. We're going to find B by using this triangle. I know this angle is 70 degrees. Alright, so let's go to this triangle where I actually know some information. I'm trying to find B. I know the angle across from it. Oh, I know 2.5 miles and the angle across from it. So I'm going to set up my law of sines. Sine of 7 degrees over 2.5 equals sine of 153 degrees over B. Cross multiply, divide. I get that B is 9.313. I wrote this out with 3 decimal places because I really don't want to round to the very end of my answer, and that at least gave me some numbers to write down. Do try in your calculator not to round though. But I'm going to bring that down here is 9.313. Now for this triangle, I know the hypotenuse, I'm trying to find the adjacent. So cosine of 70 degrees equals D over 9.313. I got that D was 3.185, or let's just say roughly 3.2 miles. So the boat is about 3.2 miles from the shore.